All right. So this is what I'm going to do today. The 2 by 2, in general, the A, B, C, D, without having a number, it can be a little bit annoying, but it's a fun process to go through. I'm going to do Gauss elimination, or actually Gauss-Jordan elimination. I'll put it in there. Gauss-Jordan elimination to this generality A, B, C, D, right? Okay. So I'm going to formulate what A inverse is. Right, bear with me. So how do we find um, inverse? What's the procedure? You write A, B, C, D here, right? A, B, C, D, and what square matrix do you put here? 1, 0, 0, 1. What is the name of that? Identity matrix, right? Now we're reducing it. So I'm not going to write first row since the second row is all in this generality because it's going to be a little bit bulky. So I'm going to write the second row first. So what is the second row? I'm going to multiply A in the denominator, first row, right? A in the denominator. So that's going to be canceled, becoming -1. So if I add, I'm going to insert C in there. Hope you see if I multiply to that leading position, and if A is non-zero, that's one thing that you have to think about. But let's say it's A non-zero, then that's going to be a negative C in there. Is that right? If I multiply that to the first row and add it to the second row. So let's see, if I multiply to the second row, what do you see? Do you see it's negative BC divided by A? Is that right? If I multiply this to the first row, writing underneath it, BC negative AC. Fair enough? If I multiply that to the first row, it's a negative C over A. Good? Multiply to that, the first row is a 0. Any question? This bottom row here is a negative C over A scalar multiplication to the row R1. Good? Now we're adding this one to get 0. Is that right? This one, I'm going to do it over here, D minus BC over A. Isn't that right, if you add these two? So the common denominator is A. And what is the first term here? A times D. Is that right? If you put the common denominator, that's what that is. Okay? So turns out this AD minus BC is a very important quantity. You're going to keep appearing in here. So it's wiser to just call that one one quantity like that, and it's easier to handle. So I hope you see that this part here is a D in the denominator. What is it? Negative, apologize, D over there, and A in the denominator. Is that right? That's what it is. And how about this one? It's just simply negative C over A. Good. And if you add this one, is a 1. And nothing happens. The first row, 0, 1, 0. Any question? Okay, so this is 0 now. Now to make this one 1, I'm going to multiply reciprocal of that, and that's going to be 1, right? So took care of that, and then I have to, take care of this position above that leading position. So if I divide that, it's a 0, 1 there, right? By multiplying D over A over D to the second row. Good? And replace that itself. So that's that. So if you multiply that, do you see that AA cancel? And then you have negative C over D. Fair enough? If you multiply that, it's A over D. Good? And then I keep the first row, A, B, and 1, 0. Any question? Now I have to multiply negative B and add it there, right? So I'm going to keep that in there. So the first row, you multiply negative B to the second row and add it to the first row to remove that to become a 0. That's the reduced echelon form, right? So let's work on that one here. A is there. A is the same, correct? And this is going to be 0. So if you multiply that, I see the BC negative B. Yes, negative BC, the positive BC is all right. So 1 plus positive BC. Let me work on it here. 1, if you multiply negative B, it's a plus BC over D. That's this part there. Negative multiply there. So what is D? Is a D there. It's a D my plus BC was AD minus BC. That's what D was, and the plus BC in there, and that's D. So it is AD. So it's AD divided by D. So that's what it is. Altogether, if you work that out, AD divided by D. Okay, so that's one, came from that one. Multiply negative 2b there is a positive BC in the numerator and denominator D. So common denominator, DD. D was AD minus BC. Let me rewrite it. D minus the BC cancels. I left with AD divided by D. Good? So that's where it's there. Now that's 0 if you just multiply negative b in there. So that's negative AB D. I have this right? Negative b multiplied there. Yes. Good. And what is the bottom row? 0, 1, negative c over d, a over d. Good? Any questions so far? Yes. Yes, uppercase D is the shorthand for AD minus BC. Yeah. Anything else? Now, how do you enter final reduced row echelon form? Dividing first row by A, right? So if you do that, is 1, 0 and 0, 1. You can see A cancel. So D over D. Good. A cancel, negative B over D. And this is negative C over D and A over D. That's the final answer. Okay? So if you started with A, B, C, D 2 by 2 matrix, what is the inverse of that matrix A inverse? Is that one, right? But notice that D is in the common in all the 4 entries as a scalar. So we can factor that out like 1 over D, right? Then it's distributed back. You can see it's the same thing. So what are you left with? The numerator, D, what is it? Minus B, minus C, and A, right? Original location was A and D. They are swapped around, right? A and D swapped around, the diagonal, and B, C stays in that same position, but change the sign. And there is a scalar you have to take care of. What is that? Down there, D, capital D is AD minus BC. Yeah. So that's a formula. AD minus BC, that's a scalar out there. And D, negative B, negative C, and A. And this whole thing is a problem if A was 0 because we divide everything by A, right? At the beginning, that doesn't work. And then you have to swap it around. Or if this AD minus BC equals 0, that's also a problem, right? You can't do this process. But it turns out that is important criteria. This AD minus BC, if that becoming 0 or not, is actually equivalent to there's an inverse or not. So you don't have to reduce it. Just try this AD minus BC. If that's 0, this formula doesn't work. So our effort of finding inverse failed. But if you look at this whole entire calculation, you can argue a little bit better and conclude that it's actually equivalent condition. So I skipped that argument part. Okay? So it turns out this AD minus BC is an important quantity associated to that. And there is quantity like that for 3 by 3 and 4 by 4, things like that. Does anyone know the name of this AD minus BC? It starts with a D. It was a determinant. Determinant of this 2 by 2 matrix. Determinant of this matrix A, right? So what's so important about this determinant? If determinant is 0, this formula doesn't work, right? And with more argument, you can conclude that the inverse does not exist. AD minus BC, inverse does not exist. Knowing this matrix is invertible or not in mathematics is very important. Sometimes they want formula rather than thinking about what happened when you go through this elimination method. So they value this a lot, important quantity in the mathematics. Okay, so that's the formula. And I'd like to challenge you with that. I want you to hide your notes. And whenever you have to find inverse of a 2 by 2 matrix, right? I don't want you to do reduction and enter 2 by 4 augmented matrix and reduce it. I just want you to use this formula, right? Please hide it with your calculator, with your arm. Go to the next page, something like that. State the inverse of this matrix AB, CD. There is something important quantity called, what is that? Determinant. Remember that part, one step. There's something about diagonal part. What happens to diagonal part when you enter inverse? What about this off diagonal part? What happens to that? Try to remember step by step like that. And just to state that, right? All right. They often write it like this, AD. We didn't name this one A, so we write the matrix like that, and up there you can write inverse like that. Is that okay? You write the whole, expression of matrix, you can put -1 in the exponent. And is equal to, what is these entries? What happened to diagonal? They swap, right? D goes up there and A down there, correct? BC stays in there, but something happens. What was that? They changed to negative, right? Okay, but what was the scalar out there? 1 over AD minus BC. The name of the denominator only is called determinant, not 1 over AD minus BC. Determinant is AD minus BC alone. Good? Okay. Don't be offended by the following slides. You can just look and enjoy, right? All right. Next one. I'm just going to show you the next one in here. I tried the same thing with 3 by 3. I didn't have patience doing that by hand, so I used Mathematica machine. Type that in. This is how you find the inverse, right? A, B, C, D, E, F, G, H, I, right? So and this is very misleading amount of space right there, okay? It actually turns out this guy, yeah, you're not going to memorize any of this part. There will be a step by step to get to that number. But if you just wanted to see, these days you have machine that back then those mathematicians in 1800 did this by hand probably and figure out, look at that denominators. They're all the same, right? Look at this denominator. They're all the same, right? Yeah. What do they call? What is the denominator called? Right there. That's the formula. What is this one called? Determinant of that 3 by 3 matrix. If this is 0, what happens? That 3 by 3 matrix is not invertible. It's a singular matrix. Right? That's the determinant. Yes, sir. Yeah, you have to pull it out. The good observation. Yeah. It is only differ by the negative sign. Yes. Okay. So, hey, why not? I did the 4 by 4. The machine runs in the. This is only the one column. Did you notice that? It couldn't fit. This is only first column of 4 by 4. There's 3 more columns to that side. It couldn't fit. Right? Yes, sir.